Welcome to the 12th lecture on computational mathematics with Sage Math. In this lecture, we are going to learn about classes in Python very briefly. So let us get started. As you know, Python is an object-oriented programming language, and classes and objects are two main aspects of any object-oriented programming language. So, we will see how to create classes and what are the objects. Let us look at, suppose we create Z, a complex number which is 3 minus 5i. Once we create this in Python, so Z is a variable, actually it is an object of some class. So, if we look at what is type of Z, it says complex. So, that means Z is an object from the class called complex, and we have seen we can apply some methods to this Z. So, for example, if I ask it to look at Z dot real, then we will get value, the real value of Z, which is 3. Similarly, if I say Z dot imag, imaginary part, this will give me minus 5. So, real part and imaginary part we are able to find out from this Z and using attribute real and imag. Similarly, you can look at Z dot conjugate and open round bracket. It will give you the conjugate of Z, which is 3 plus 5j. So, in this case already you can see here Z, when we have created this object Z, some attributes, you can say variables and methods, you are able to apply on Z. So, this is already an example of a class in which you have some attributes and methods. Okay. So, in general, how do we create these type of classes on our own? This is what we are going to study. So, if I say print Z, it tells you what is this Z. So, where is this print coming from this class? This again we will see. So, in this case, actually what we have done, we have created Z as an object or instance of the type complex, which is also known as class, and it supports attributes like real and img, that is what we saw, and a method in this case known as conjugate. So, in this case you can just notice when we have said Z dot imag, there is no empty round bracket, whereas Z dot conjugate ends with empty round bracket. That is because conjugate is a method, whereas this is just an attribute to this class. So, we will see more details on this. So, even if you ask, if you define one more complex number, let us say w, which is 2 plus 3i and Z is 3 minus 5j, then you can add Z and w, you can multiply Z and w. Okay. So, again these operations are permitted when you create or these operations are permitted inside this complex class. Okay. So, all these things we will see in today's class. So, operators, attributes like real, img, and methods like conjugate, these actually provide interface to an object. In this case, the object is Z and w, and which can be accessed using dot operator. That is what we have seen, z dot real, z dot img, z dot conjugate, all these things can be accessed through dot operator. Okay. So, now let us look at what are the classes and objects. So, as I said, classes are actually building blocks of Python. A class creates a new type and an object is an instance or a variable of that particular class. Actually, you can think of class as a blueprint or a template using which you create objects. One can think of class as a factory of objects. So, several objects you can create with the same class or same type. In fact, in Python everything is an object or instance, and we have seen several of it. For example, we have seen lists, we have seen tuples, we have seen strings, floating point numbers, integers, complex numbers, and so on. These are all classes in Python with class name as list, tuple, str for strings, float for floating point numbers, int, complex, etc. Okay. So, it is good to know how to create classes, and when you have methods inside these classes, how does it look like. And since Sage Math is based on Python programming, and which is also an open source package, so many times you will be looking at the source code of some function or some methods, and in that case you should know what when you are reading this help document or a source code, you should be able to understand by this knowledge. So, that is the basic idea behind introducing these classes in today's lecture. Okay. Now, let us see how to create classes. So, to create class, you need to define the keyword class and followed by the name of the class. So, in this case I am calling the name as student, S capital, and then colon, and then if you the simplest class could be a class which is we call as empty class, and you do not write any statement here, you simply write pass. Okay. So, this is the simplest of a class you can think of. Now, what we can do, we can define an object of this class or instance of this class. And how do we define that? So, we will call this as S1. S1 is an object which has student class or student type. So, we say S1 is equal to student and empty round bracket. So, let me execute this. So, we have created S1 as an object of this student class, and you can create many more objects. I can create another student S2, I can create one more S3, S4, or as many as you want. Okay. So, at present S1, S2 are just objects which are student type, student class, but it does not have anything inside. Okay. It does not have any attribute. As we saw in case of complex number, it has an attribute real, imag, and other things. Okay. So, how do we add attributes to any student class? Okay. So, in order to add attributes, what you need to do, you simply write S1. Let us say we want to create an attribute name of the student. So, we will say S1 dot name, and then let us say is equal to the name is John. Similarly, let us say the roll number of S1. How do we create? S1 dot roll, and this roll number is, let us say, M80-101, or you can have anything. Similarly, we can create S1 date of birth of S1 as S1 dot DOB, date of birth, and let us say the date of birth is July 1995, 15th July 1995. Similarly, we can create another attribute grade and it can be created as s1 dot grade. So let me run all these things. Now you have created 1, 2, 3, 4 attributes to s1, which are name, roll number, date of birth and grades, right. Similarly, you can now how do we access these attributes? So you can simply type s1 dot name, it will give you the name John. If I say s1 dot date of birth, it will give me July 15. If I say s1 print, you don't need to say print, you can simply, in this case you can say s1 dot, let us say grade, it will give you the grade. If I want to access anything else which we have not created, it will not be available. So for example, if I say s1 dot let us say gender, it tells me that s1, the student object, has no attribute called gender. Okay. So in order to access this, you need to create these attributes. Okay. Similarly, you can create another student, let us say we have already created another student s2, right, with the same type student, and in that we can add again some attributes, and it is not necessary that s1 and s2 have the same attributes. You can have different attributes of the same class. You can have different attributes, object can have different attributes, right. So for example, in this case the attribute is name, which is Sarah, roll, which is MAT111, which is, and then date of birth is August 26, 1999, and it has another attribute called average, which is, let us say, 85.6. Okay. So again you can print these things, these attributes from s1 of s1 using dot operator, right. And in this case, suppose you at some point, if you want to delete some attribute. So for example, let us say we want to delete grade of the first student s1. So that you can achieve using del function, del space s1 dot grade. Now if you ask for what is grade of s1, it will tell you that this particular attribute does not exist. The student object has no attribute grade. Now you can see this, we have not created this del for this student class, but it is available. So there are some default attributes, we will look at several of them, right. So if you look at how we have defined this student class, so there are two things that you have to remember. First, you have to put here colon, and then all these statements should be indented inside. Okay, right. So that is, these are the things you must keep in mind. Now let us look at how we can create a non-empty class, or class in which we want to define some methods. Okay. For example, in case of complex class, you saw there is a method called conjugate. Now in this case, student class, let us say we want to define some method. So how do we do that? Let us see. So so what we can do is, first again let us define class and space student colon, and let me give you let us give a variable total is equal to 0. So this is actually called class variable, and we are initializing it equal to 0. So what we are thinking is that the total number of students, right. Now we can so the basic idea is, as you create the objects inside this class, each time it should add the number of students. Okay. Now next is you create a method which is called init, which is again a default method. This is also known as initialization, right. So how do we create? You just type in the def and space two underscores init followed by again two underscores, and then you inside the bracket you have to give the arguments. By default this will have an argument called self. So this is a default argument, you have to give it, and then we are giving two variables here, which is the name and role, and these are called object variables. So how do we write this? So you have to say self dot name is equal to the name, that parameter which has been passed, and self dot role is equal to role that you have entered. Okay, and then every time a student is added or an instance or object is created, you want to add the total number of student, right. So add this, and since this is a class variable, this class variable you have to access using student dot total plus equal to 1, that means student will increment by 1. And then let us also print, once a student is added, you print that a student with whatever name is added with whatever roll number, and then you also print what is the total number of students. Okay. So let us create this, and once we have created this student class, then we can keep on adding the different students. That means we can create objects, as many objects as you want. And of course in this case, as you saw this here, this method init has one argument which is self, and we do not actually pass any value to this parameter. Okay. So when we create an object, we do not need to say S1 is equal to student and then in the bracket self. We have to simply give the name and the roll number, right. So that is what it means. So whenever an object is created, Python will provide its value automatically. That is the role of self.name, self.role. Okay. So let us create an object. Then object is S1, which is student, the name is John, and its roll number is M80-101. So let us run this. Now again you can see here, the moment I have added one student with name John with roll number M80-101, it gives me this print, a new student John is added with roll number this, and the total number of student is 1. That is what we have done. We have added only one student, and that is coming from these two print statements, right. Suppose we create another student. So now we can also print what is the S1. Now when I say print S1, it does not give me anything, right. Whereas in case of Z, when you created Z and when you asked for print Z, it actually printed. So we will come to this when we have created this particular class. It does not know what is meaning of print, and that can be taken care using some other method that we will come to it later. Okay. Now let us say create another student called Sarah and with roll number M80-111. So when we create this, what will it display? It will display that a new student called Sarah is added and with roll number this, and the now total number of student is 2. Okay. So if you create one more student, it will say let us say another student S3, which is equal to student, and let us say its name is Ramesh, and its roll number is, let us say, 2001. Okay. So now it says that Ramesh is added with roll number 2001 and the number of student is 3. Okay. So that is the way one can create class with initialization, and then one can keep on adding the attributes to this class. Okay. You can access total number of student, which is a class variable in this case, using student dot total. So if I say student dot total, now the 3 students have been added, so it gives you total. Okay. And so in this case, as you can see, we have created 2 types of variables. One is class variable, which is outside any method, and then you have object variables. For example, here in this case, name and roll number, they are all object variables, and or the attributes of this particular class, this particular student class. So for each student you can have different attributes. For each object you can have different attributes, whereas this class variable, that will be common to all the objects. That's the difference between class variable and object variable. Okay. So that's what is explained here. There are 2 types of variables: class variables and object variables. Class variables are owned by the class, and object variables are owned by each object. If the class has n number of objects, for example, in this case we created 3 objects, then there will be n separate copies of object variables, and the object variables are not shared between objects. So for example, we saw that S2 and S1 have different attributes. So if for example, earlier we created S2 attributes for S2 as was average, whereas one attribute for S1 was grade. But if you ask for S1 dot average, it will not give you. Similarly, if you say S2 dot grade, it will not give you anything. It will say attributes are not available. Okay. So the object variables are not shared between the different objects, whereas class variables are common to all the objects. Now, and changes made to an object, just one second, changes made to object variable by one object does not reflect in other objects. You can change, for example, we have created 2 variables S1 and S2. If I change the roll number of S2, the roll number of S1 will remain unchanged. Now, right, if a class has one class variable, then there will be only one copy of variable, and all objects of that class will share the class variable, right. That is what we saw. We have here one class variable called total, and that is common to all the objects. Okay. Next, let us create another method inside this student class. We created one default method called initialization, but let us create our own method, and let us say we want to create a method called get marks to get marks of a particular student, and this marks we will get as a list of marks. It may be list of marks in 5 subjects or 4 subjects or as many subjects as you want. And then another one, we want to, once you have given the marks of the student, then we want to print the average of the marks. So these are the 2 new methods we are creating inside this student class. So how do we create? So again, creating method is very similar to creating a function. So we'll say def, the name as get marks, and again the first parameter will be self, this is default parameter, and then this list of marks, I am calling it as variable marks. And now so let us create a variable called total marks. And how do we create that total marks? So in this case, already we have created one variable in initialization called total marks, and which we initialized as 0 marks. So initially it has 0 marks, and then so for m in marks, that is the list, you simply say self dot total underscore marks plus equal to m. That means for every m inside this marks, it will get added to this total marks, and then let us print the average. Let us create the average, which is self dot average. So this is what the total marks divided by the number of subjects for which you have entered the marks, and then create another method called average, and that we are not passing any argument except the self, except that default argument self. And what should it return? It should return self dot average, which we have calculated here. Okay, so let us run this. So when we run this, now let us create an object called S1. So let me go one by one. So this is an object called S1, which is student with name John and the roll number M80-101, and again it is displaying these two messages, that is coming from these two print statement which we have created already inside this initialization itself, right. And after that, let us get the marks. So how do we get the marks? We have to say S1 dot get marks. And what is the parameter we need to pass? We need to pass parameter the marks as a list. That is what we have decided. So this is the, now if I say S1 dot marks, it doesn't have any attribute marks. That is why you are not able to access. Okay. Now let us look at what is S1 dot total marks. Total marks. This we have defined, and this is total marks is 921. I think there is something wrong in this. Let me run this again, and let us call this S1 and get marks. That's correct. So it was actually initialized as something, right. So the total marks is 307. If I want to get what is the average, I can simply now access that average method as S1 dot average and empty round bracket. Why only empty round bracket? Because we have not asked for any parameter here, okay, any argument. So we will simply say S1 dot average. This is the last one which is printing. S1 dot average is, okay. So you can see here this is keeps on increasing because we are adding these marks. So that is why it is printing. So let us reinitialize, and then when we say this average, the average is 76.575. Similarly, you can add another student and create its average. Now if I ask for S1 dot age is equal to 20, though we have not created the age variable here, age is not a variable, okay, no, it is not an attribute, but suppose if I say S1 dot age is equal to 20, then it will add, okay. So even though you have initialized using init method, still you can add attributes to any object. That is what it means, right. So if you look at this init method, this is what is called a class construction. This is a constructor method, and so it always starts with 2 underscores follow with name init, and then again 2 underscores, and inside the bracket you write the arguments, first self and then followed by the arguments or initial values, right. So this is what is called spatial method. This is known as spatial method, and as soon as an object is created, this method will get executed, okay. And this method is useful to initialize the variables of the class. That's what I said, okay. Inside this init constructor method, the argument self is a variable holding the new instance to be constructed, right. And there are several other spatial methods. Some of the methods are for comparing objects, some of the methods are for printing, and so on. So we will see a few of them. First, let us look at another method, another spatial method called call, right. So for example, when you created a function in core Python, when you created a function, you could also call it, right. Suppose if I create a function f(x) equal to some sin x plus x square, then if I say f of 2, it will give me the value of the function. It will evaluate the value of the function at 2. So, this is what is inside this class. There is a method, special method called call, and the role of this call is exactly that. Okay. So, let us see how do we create that. So, let us create a class to calculate numerical first order derivative, right. So, you must have seen the derivative as a limiting limit of the difference quotient. That is, if I want to find derivative of a function f at a point x, then you look at f of x plus h minus f of x divided by h and take the limit of this function as h goes to 0. Therefore, as h becomes small and small, this f of x plus h minus f of x by h, this is approximately very close to the derivative of this function. So, that is what it returns. And so, how do we create this class? So, class name is derivative, and inside that you create the initial init method with self and the function, and then this is the error term, that is the h value. So, by default it is taking 10 to the power minus 8. You can change this, and then store this f in self dot f and h in self dot h, and this somebody may give this integer value. So, in that case you convert into float, okay, and then call these methods called def, again 2 underscores call 2 underscores and then self, and you want to call this at some point x. So, and what is it going to do? So, f and h, I am just reinitializing f and h as self dot f self dot h, and then return this the difference quotient. Okay. So, let us run this. When you run this, now how do I call this this derivative? So, let us say we want to find derivative of sin x. Okay. So, let us import sine and cosine, and we want to evaluate the derivative at, let us say, pi by 4. So, let us import this from math module, and then define df is equal to derivative of the function sine, that is f, and this is the value of h. By default it is not necessary to give this value, then in that case it will take the default value as 10 to the power minus 8, and so the derivative has been created of sine. And if I am to evaluate this at x0 is equal to pi by 4, and in that case we will say df x0. So, that is how you call a function to be evaluated at some point.